So it's unit 1, dynamic universe. Okay, so we underline underneath that. All right. So what first thing I'm going to look at is what a scalar quantity is. So scalar quantity is fully defined by its magnitude or size and a unit. Okay, so e.g. temperature. Vector quantity is fully defined by its magnitude direction and a unit. Okay, so give a couple of examples. E.g. temperature, vector quantity, e.g. force. Okay, now one quick thing. Let's just a quick guide or rule of thumb. Could I say the temperature of the room was 15 degrees Celsius west? Well, I'm hoping you're all saying, no, you can't say that because it makes no sense. And this is the thing, if you attach a direction to a quantity and it makes no sense, it must be a scalar. If it does make sense, like force exerted was 100 newtons north, I guess you could push something north, that makes sense. So that does make sense, yes, because it's a vector. Okay, so just keep that in mind. The only exceptions is, and this is be careful, let's just change that down. Be careful of speed and distance. Okay, now can you remember what they are? They are, of course, scalars. All right, now let me just go into this just now. So speed, distance, time. And let's look at velocity, displacement, time. So distance hang on a minute. Distance is how far an object travelled. Okay, doesn't matter what direction it went in, it's physically how many meters it went. Whereas displacement is how far away and in what direction an object is from its starting point. Okay, so they're different things. So speed equals distance over time, and velocity, equals displacement. Over time. So they're quite different. Let's go through the consequences of that. Okay, so let's just take example. All right, so a boy takes a run, goes for a run. could be a girl, doesn't matter, goes for a run. And they run 10 metres that way, and then they run 3 metres back way. Alright, and the time to do that is 10 seconds. So, first question, speed. What's the speed? Distance over time, which equals, well, what's the distance? Have a think. 10 plus 3 over 10 seconds. So it's 13 over 10, 1.3 metres per second. Okay? Velocity, on the other hand, is displacement. Now, I'm going to clarify something here. The symbol for displacement is actually an S. Okay, we'll get used to that, don't worry. You'll get used to it. Now, what's the displacement? How far is this person from the starting point? Well, there they are. Their distance from the starting point is actually 7 metres, or 10 minus 3 over, still 10 seconds. So that gives them 7 over 10. So their velocity is 0.7 metres per second. But because velocity is a vector, what have I got to include? I've got to include a direction. So, for the sake of this diagram, I'm going to take, look at the top of the page here, let's just take that as north. I have to define that. Let's just say, well, if he ends up, well, I've made a mistake there, let's get rid of this. Sorry. Okay. It's 0.7 meters per second at, now can you remember what the bearing is for east? 0, 9, 0. Okay, so that's fine. So we have to be able to use these two equations, speed and velocity. They're different things. Okay, incidentally, displacement would be 7 meters at 090. So displacement okay, 7 meters at 090. The direction of velocity is just the same as the direction of the displacement that you're using in the calculation. Okay, and the last thing, just in case if you can't remember this, don't worry, but we did do this at the end of just about before the lockdown finished. Let's say that somebody else call this example 2, call that example 1, let's call this example 2. I'll do this quite quickly, because it's, let's just say, this one is slightly different. They go up 8 meters, so the person goes for another run. Okay, go up 8 meters, and they go across 4 meters. Now in this case, go through the same thing. What in the time for this case, sorry. And the time in this case, let's make the time 10 seconds again, because that's easier for me. Oh, hang on, I've got a calculator issue, I may have to come back, run off and get a calculator. But let's say, what's their speed? Okay, well that should be easy, because speed equals distance over time, that's a D. In this case, that's going to be 8 plus 4 over 10, gives you 12 over 10 equals 1.2 meters per second. Easy. But velocity is slightly different. Velocity equals S over T. Now, the displacement is not that obvious because I've got to calculate it. Now, I do that, let me change colour here. Is I have to use my resultant diagram. Now, if you remember from 4th year, you always go from start to the finish. So that's going to be, well, what's the size of that? Okay, well, we need to find, it's obviously it's just Pythagoras, so it's a squared equals b squared plus c squared equals 8 squared plus 4 squared, which is 64 plus 16, which gives you 80. And what's the root of 80? So it's 8.9 equals 8.9 meters. Okay, so that gives you a velocity displacement, sorry, of 8.9. It's actually 8.94. I'm going to go to 3 sig figs because I know how much I go on about it. Over 10 equals 0.894 metres per second. However, remember, I've got to put in a direction. Now, for those of you who remember north, what's north is 0, and I'm always interested in the line. The direction is always from the north line around to the tail of the resultant. So it's that angle here, and I'm going to use theta for angles now, because that's what we're doing higher. So let's go tan theta equals opposite over adjacent equals, now the opposite is 4. 4 over 8 is 0.5. So theta equals, let's plug it into the calculator. Try this yourselves at home. Is 26 point, or 20, I'm going to round up to 27 degrees. So therefore the velocity equals 0.89 metres per second at, and because that's 27 degrees in there now, it gives you at 0.27, okay?